This video covers how to add the LED ring and an extra Python function to the MQTT DHT11 sensor's temperature readings to mirror the Adafruit dashboard gauge you added in topic 15.05. It will follow steps in modification 2 of the web page as shown. You can use this page to see how the task is completed. Ensure you have the NeoPixel LED ring.py and MQTT with DHT11.py files open in Thonny. Begin by saving the MQTT with DHT11.py file as MQTT with DHT11gauge.py in the Practicals folder. In Thonny, access the rings file. Find the rings import statement from Unit 19 modules import RGB ring _module. Highlight and copy the rings import statement. Go to the MQTT file, locate the existing import statements. Paste in the import statement. This activity requires the inclusion of a function that will turn the ring of LEDs into a gauge. This function, called setGauge, is available on the Canvas page as shown, and requires the calling statement to send it a link to the ring of LEDs and the value it needs to show. Copy the function using right-click and the Copy this section option. Go to the MQTT file. Find the Add Functions required comment. Paste in the setGauge function below the comment. The setGauge function includes a number of values that match Adafruit IO's dashboard gauges. The first is min_val, which copying the gauge on the dashboard has its value set to -5. Next is max_val, which has its value set to 50. The low warning val has its value set to 0. And the high warning val has its value set to 32. The rest of the function's lines set the LEDs on as requires so it mirrors the gauge on the dashboard. Return to the LEDs file and find the line that creates a connection to the ring. This will be in the main function where other device connections are entered. You will need to scroll down to find it. It begins with color ring equals RGB ring. Copy the line, and if you want, the comment too. Go to the MQTT file. Find the def main function. Paste the lines just inside this function. The sensor can now be accessed using the variable color ring. You now need to add a line to call the setGauge function, giving it the color ring link and temperature now value. This line is on Canvas, so return to topic 19.03. Copy the line on step 14 of the page. Return to the MQTT file on Thonny. Scroll down to find the line that reads in the temperature value as temperature now. Look for the temperature now variable inside the if publish line and the publish to Adafruit IO comment. Paste the line just below the temperature now line. It will send the variable temperature now's reading to the function, which will set the ring's LEDs on as required. Now, you need to include the LED's release statement, so return to the ring file. Scroll down to find the release statement. Select and copy the color ring.release line statement. Return to the MQTT file and navigate to the other release statements near the bottom. Paste in the new line. Now you are ready to run the script. You need to access your Adafruit IO account's dashboard in this section. Run the script now. It will connect to the Wi-Fi and then Adafruit. This may take time. The connection process time is shortened in this example. The ring of light should illuminate now to represent a temperature gauge. The ring of LEDs can now be compared to your temperature gauge on Adafruit IO's dashboard. Here the two gauge examples are shown with the temperature at 23 degrees. Note the first two LEDs are blue to represent the low warning zone, the rest are green to represent the safe zone. Here the temperature is over the high warning limit of 32, so the display indicates this by showing a red warning light as it's above the safe zone. You can now stop the project. This completes the activity.